Hi, welcome back to ChemTube channel. Happy New Year to all of you. Today we are going to look at the Perlis trial paper 2 essay part. Let's start. Now we look at question number 7. Table shows the apparatus set up for observation of two sets of experiments to study the property of an alkali by using the red litmus paper. So for your information, if you put the litmus paper into the acid, it turns to red color. Put into the base or alkali, it turns to blue color. So now set number 1, okay, dry red litmus paper, put into the dry sodium, solid sodium hydroxide. No change in the color of the dry red litmus paper. But if you put the moist red litmus paper into the dry solid sodium hydroxide, the moist red litmus paper, it turns to blue color. So here, if you see the word moist, means it has the presence of water. So based on the table, explain the difference in the observation for both sets of experiments. Okay, so the red litmus paper returns to blue in the set number 2. Set number 1, in the dry state, the hydroxide ions in the solid hydroxide are arranged orderly in the fixed position. So dry solid sodium hydroxide does not show any alkaline properties. Then in set 2, when the moist red litmus paper is used or water is present, the sodium hydroxide ionizes in water to produce freely moving hydroxide ions. So sodium hydroxide ion can show the alkaline properties if it has a freely moving hydroxide ions. So the concept here would be the water is present. So no matter how is it, you have to remember, if water is present in the acid and alkali, then it has a free moving hydroxide ions or hydrogen ions. Then it can show the acidic or alkaline properties. Okay, B. Diagram 6 shows the pH value of two alkalis. So same concentration, one is sodium hydroxide solution, another one is ammonia solution. The concentration are the same, 0.1 mole per cubic decimeter. But they shows the different pH. Beaker A, it shows the 13. Beaker B, it shows the pH 11. So explain why the pH value of two alkalis are different. 4 marks. So here, let's see the chart here. If in the alkali, if strong alkali, the pH will be higher. If the weak alkali, the pH will be lower. In other words, here ammonia is a weaker alkali compared to sodium hydroxide. So number 1, okay, sodium hydroxide is a strong alkali, but ammonia is a weak alkali. So this is point number 1. Number 2, sodium hydroxide ionizes completely. In water, produce high concentration of hydroxide ions. Okay, then ammonia ionizes partially. In water, produce low concentration of hydroxide ions. So the higher the concentration of hydroxide ions, the higher the pH value. So there are 4 points here. Okay, C. You are required to prepare a standard solution of sodium hydroxide solution with concentration of 0.02 mole per cubic decimeter using 250 cubic centimeter of the volumetric flask and the sodium hydroxide solution from the beaker A in the diagram 6. So name the method used and determines the volume of sodium hydroxide solution needed. Okay. So number 1, you have to name the method used. Number 2 is determines the volume of sodium hydroxide solution needed. Okay. So for these questions, okay, So we have to use the dilution method. Okay, dilution method. So in order to calculate the volume of the sodium hydroxide solution needed, we have to use the formula M1V1 equals to M2V2. So let's see this explanation here. So My is the concentration of the solution before the dilution, means before you add in the water. Then V1 is the volume of solution before the dilution. M2 is concentration after dilution. Then V2 is the volume of solution after the dilution. Okay, so we add in the information given here. So M1 is 0.1. V1 is the one you need to find out volume of sodium hydroxide needed to prepare. Then M2 is the solution concentration of the diluted sodium hydroxide. Then V2 is 250. So from here we can use your calculator to calculate. Then we find out the V1 is 50 cubic centimeter. Okay, so meaning that you need to get ready 50 cubic centimeter of the sodium hydroxide solution. Then use the dilution method to prepare the 250 cubic centimeter of 0.02 mole per cubic decimeter. Predict the pH value of the sodium hydroxide solution in the volumetric flask. Explain your answer. So after you prepare the new or diluted sodium hydroxide solution, so you can predict the pH value. So meaning that the pH value will be lower than 13, meaning that now will be less concentrated. So because the concentration of hydroxide ions is decreases now, the lower the concentration of hydroxide ions, the lower the pH value. So there are 3 marks here. 25 cubic centimeter of sulfuric acid is needed to react completely with 25 cubic centimeter of sodium hydroxide solution prepared in 7C. State the type of reaction occur and write the balanced chemical equation. Then calculate the concentration of sulfuric acid needed. So there are a few questions here. So 6 marks. Number 1, we have to write out the type of reaction. Okay, it's a neutralization reaction. Then write out the balanced chemical equation. So sulfuric acid react with sodium hydroxide. So produce the sodium sulfate and the water. Then we need to balance the equation. Okay. So in order to calculate the concentration, okay, so we have to use the formula. Okay, so here we have to look into the, if here 2 means 2 moles, then sulfuric acid will be 1 mole. So we use the formula MAVA over MBBB equals to A over B. Then remember A will be for acid, B for base. So we standardize it. So we're replacing all the information given. So you need to find out the sulfuric concentration of sulfuric acid, means you need to find out the MA. Then we replace in VA is 25. Okay, volume of sulfuric acid. Then this is the volume of alkali sodium hydroxide, so it's 25 also. Then concentration is 0.02. Yeah, this one is from the previous question. So 0.02. Okay, then here is 1 over 2. A is for the acid is 1. Then B is from the alkali, so it's 2, 1 over 2. So we use the cross multiply, we can find out the MA. So MA is 0.01 mole per cubic decimeter. So if you have any question, you can leave at the comment below. Okay. Now we look at question number 8. The following are formulae for 2 of compounds, MgCl2 and Fe2O3. Based on the formulae, state the oxidation numbers for magnesium and iron, and then state the name of the compound. So number one, okay, well, let's look into the structure. Magnesium is MgCl2, means it consists of magnesium ions and 2 chloride ions. So it forms the MgCl2. So for another one is iron 3 oxide. So iron 3 means it's iron 3 positive. There are 2 of it. Then there are 3 oxide ions. So the charge are balanced, are neutral. Okay, so number one, oxidation number for magnesium is +2. Okay, +2. Then number two, the oxidation number for iron or ferrum here will be +3. Oh, +3. So how about the name? Number one, MgCl2 is a magnesium chloride. Okay, magnesium chloride. Then Fe2O3 is iron 3 oxide. Iron 3 oxide or ferrum 3 oxide also accepted. Okay, diagram shows the apparatus set up for experiment to determine the order of metal Y, magnesium, and metal Z in the reactivity series of metal towards the oxygen. So potassium magnate 7 are heated to release the oxygen gas to react with the metals. So this is heated strongly, then you will release the oxygen gas. Then it will pass through the glass wool here. Then the metals also heated strongly. Then oxygen can react with the hot metal here. So actually, if we want to see to know the reactivity, we can see the flame produced. Okay. Now I show you a video to show for the reactivity of the metals towards the towards the oxygen.
Let's do a lab activity to compare the reactivity of metals with oxygen series of metals.
So if the aluminium react with oxygen, so it burns. It burns. Okay. Then for copper is not burning, it just glows only and produce a black solid. Okay, this one is iron with oxygen. This is lead with oxygen. And this is zinc with oxygen.
This arrangement is called the reactivity series.
Okay, so based on the flame produced, we can arrange them into the reactivity series. Okay, now we look into the observation. Okay, why it glows faintly, then it forms a black residue. Magnesium, it burns with bright flame, then white residue is formed. For Z, glows brightly, yellow residue when hot, and white when cold is formed. Okay, so from here actually there are some very popular information. Okay, if it glows means less reactive. Okay, glows less reactive. Burns means more reactive. In other words, this one is the most reactive, followed by Z. Then finally is the least reactive will be this one. Okay, now from the residue produced here, the color, we can also predict metal Y and metal Z. Okay, in actual fact, if you see the black residue is formed, actually is referred to copper oxide is formed. So in other words, metal Y is copper. Then another one is yellow residue when hot and white when cold. In other words, this is the zinc oxide. Zinc oxide. So in other words, this is a zinc. Okay, so state the type of reaction when oxygen react with metals. So 1 mark. This is a redox reaction. Then based on the observation in table 5, identify the Y and Z. Arrange them in the descending order based on their reactivity. Then finally write the chemical equation. Okay, so if here we can arrange like this. Magnesium is the most reactive, as I mentioned just now. This is number 2. Okay, so this is the zinc. Then finally is the copper. Okay, then we arrange in the descending order. Descending order here will be from magnesium to zinc. Okay, so metal Y is copper, metal Z is zinc. Then arrange in a descending order, so magnesium, zinc, and copper. You can also replace it with the zinc and copper here. Then finally, chemical equation. So magnesium react with oxygen, produce a magnesium oxide. So it produce. I write the we have to balance the equation. 2 magnesium react with oxygen, produce 2 moles of magnesium oxide. So total 5 marks. Then 2 sets of experiments to carry out to study the effect of other metals on the rusting of iron. Set 1, iron nail coil with the metal R, whereas set 2, iron nail coil with metal S. So both of the coil iron nails are dipped into the hot jelly solution containing potassium hexacyanoferrate 3 and phenolphthalein. The result are shown in the table 6. Okay, there are 2 chemicals in the solution here. Potassium hexacyanoferrate. Okay, so just remember it used to detect the presence of iron 2 ions. In other words, if rusting occur, it shows a blue color because the presence of iron 2 ions. If no rusting, okay, the phenolphthalein actually if producer detect the presence of hydroxide ions, and it shows a pink color. Okay, so the hot jelly solution contains the both chemicals here. The metal R coiled with iron nail. Then after a few days, okay, then the dark blue color forms. So meaning that this iron nail rust because the presence of iron 2 ions. So in other words, metal R will be lower than iron in the electrochemical series. Okay, so now I show you one video.
We shall study the effect of some metals on the rusting of iron. The metals chosen are magnesium and zinc, which is more electropositive than iron, and the less electropositive copper. Iron and iron metal pair is set up as a control.
Potassium hexacyanoferrate is added to detect the presence of iron 2 ions. Okay, then pour into the test tube. Contains the metal. This one is the iron itself. So it's as a control. So after 1 day, so you can see a little bit blue color form, means the iron nail rusts a little bit. So this one is iron with magnesium, so there is no blue color is formed, so just forms a pink color, so no rusting. So iron with copper, so after 1 day, yes, you will see the blue color form. Then iron with zinc, so no blue color also. Okay. So based on here, the video just now, okay, we can see the metal R should be something metals that lower than iron in the electrochemical series. So we can, let's say we choose it is a copper, okay, or lead also can. Okay, next one, okay, the metal S with pink color means it is not rusted. No rusting occur, so it forms a pink color, so means hydroxide ions is present. So metal S should be some metals higher than iron in the electrochemical series. So if you have done these experiments, so you will see this is the result. this is no rusting, this one is the rusting occur. Okay, based on the observation, suggest the method R and method S. In each set of experiment, explain the observation and include the half equation. Set the metal that is oxidized. So 10 marks. So here, okay, metal R, you can choose it be tin, lead, copper or silver. Okay, just now I mentioned is copper. Okay, you can choose any one of these. So metal S will be magnesium, aluminium or zinc. Okay, so set 1. Okay, so iron rust or corrode. Iron is more electropositive than R. So iron 2 ions is formed. Then iron, it forms the 2 positive, iron 2 positive by release 2 electrons, so undergoes oxidation. So iron is oxidized. In set 2, iron does not rust because no blue color, that blue color is formed. Because iron is less electropositive than S, and the presence of hydroxide ions, so oxygen with the water then gain 4 electrons to form the 4 hydroxide ions. So metal S is oxidized, so it protects the iron nail from rusting actually. Question number 9. 2 experiments were carried out by students to investigate the factor that affects the rate of reaction between the metal Y and Z acid. So, experiment 1, access powder of metal Y with the 50 cubic centimeter of 1 mole per cubic decimeter Z acid. The time taken for the reaction will be 10 seconds. For set 2, granulated metal Y, same concentration and volume of Z acid. The time taken is the 20 seconds. So now I show you the experiment. Actually, how do we do this experiment?
Let's watch how to carry out this experiment. Fill a burette with water and invert it over a basin containing water. Clamp the burette to the retort stand. Record the initial level of water in the burette. Measure and place 1 gram of marble powder into the conical flask. Measure and add 50 cubic centimeter of hydrochloric acid into the conical flask. Quickly insert the rubber stopper into the mouth of the conical flask and start the stopwatch simultaneously. Record the amount of gas released by the reaction every 30 seconds. Repeat the experiment. Replace marble powder with 1.0 gram of marble chips and then 1.0 gram of small marble blocks.
Okay, so in the video, it actually used the 3 sets of experiment, use the different size of the marble chips. So here actually is two types of the total surface area. One is a powder form, another one is granulated. Okay, so here name the one example of the metal Y and one example of Z acid. By using the metal Y and Z, name acid. Write the balanced chemical equation. So there are 4 marks here. So here we can choose the Y, you can choose magnesium, zinc or aluminium, but we reject the sodium or potassium. So Z, we can use any acid. Can be monoprotic acid, can be diprotic acid, hydrochloric acid, sulfuric acid or nitric acid. Okay, but you have to use the name. You cannot write the formula, because the question asks you to name it. Then we can also accept the weak acid, for example, acetic acid, ethanoic acid. The chemical equation, so let's say we choose magnesium. react with hydrochloric acid. So it react with 2 moles of hydrochloric acid, produce a salt, magnesium chloride, and hydrogen gas. Oh? So we can collect the gas then to determine the rate of reaction. Then calculate the average rate of reaction for experiment 1 and 2, 2 marks. So average rate of reaction, we can actually use the formula, change in the amount of the reactants or products over the time. So here, the experiment 1, so average rate of reaction will be 30, volume of the gas collected divided by the time is 10 seconds. So it's 3 cubic centimeter per second. For experiment 2, so 30 over the 20 seconds, so 1.5 cubic centimeter per second. So you have to write the unit correctly. So meaning that set 1 has a higher rate of reaction, set 2 has a lower rate of reaction. Okay, compare the rate of reaction between the experiment 1 and 2. Explain your answer using the collision theory. So for collision theory, for effective collision, the collision must collide with correct orientation and it has achieved activation energy, overcome the activation energy, that it produces the products. Otherwise, it becomes ineffective collisions. So rate of reaction in the experiment 1 is higher than experiment 2 because the size of the metal Y in experiment 1 is smaller than experiment 2. Or you can mention total surface area for the Y in the experiment 1 is larger than experiment 2. So frequency of collisions between the hydrogen ions from the acid naturally. Then the zinc atoms of the Y in the experiment 1 is higher than experiment 2. Then frequency of effective collisions in the experiment 1 is higher than experiment 2. So 4 marks. So frequency of collisions between the particles, you have to mention the particles correctly, and then you have to mention the effective collisions. So this is how we use the collision theory to explain and then to get the marks. B. Describe experiment how a factor of temperature of reactants or presence of catalyst affect the rate of reaction. Okay, so 10 marks. So this one you have to explain in details how you do the experiment. So here I show you one video.
Draw an X about 2 by 2 centimeters in the center of a piece of white paper. Measure out 25 cubic centimeter of 0.5 mol per cubic decimeter sodium thiosulfate solution using a 100 milliliter measuring cylinder. Pour the sodium thiosulfate solution into a clean, dry conical flask. Heat the conical flask to 30 degrees Celsius. Measure the temperature of the solution with a thermometer. Record the temperature reading. Place the white paper with the X mark on the magnetic stirrer. Place the conical flask on the white paper. Measure 5 cubic centimeter of 0.5 mol per cubic decimeter of sulfuric acid. Pour the sulfuric acid into the sodium thiosulfate solution at one go. Start the stopwatch and magnetic stirrer immediately. View the X from above and stop the stopwatch as soon as the X cannot be seen. Record the time taken for this process to occur. Repeat the experiment using the same volume and concentration of both solutions at different temperatures as shown in the table.
Okay.
Record the time taken for the process at different temperatures. Key in the recorded time in the table provided.
So record the time taken. the higher the temperature, the shorter the time taken for the X cannot be seen. So X disappear already. So 50. It disappear very, very fast from sight.
Well done.
Okay, but in the lab, normally we do not use the temperature until 60 degrees Celsius because at 60 degrees Celsius the X mark can disappear very fast. So normally we will use difference of 5 degrees Celsius. So 30, 35, 40, 45, and then 50. Okay, so now we look into the steps to produce for the temperature factor. So number 1, 50 cubic centimeter of 0.5 mole per cubic decimeter sodium hydroxide solution, sodium thiosulfate solution is measured, and then pour into a conical flask. The initial temperature of the sodium thiosulfate is recorded. Then the conical flask is placed on the top of a piece of paper marked with X. Then 5 cubic centimeter of 1.0 mole per cubic decimeter hydrochloric acid is measured. You can also use the sulfuric acid, also can be used, measure. And then hydrochloric acid is poured quickly into the conical flask. Then a stopwatch is started immediately. Then the conical flask is swirled throughout the experiment. Then time taken for the X mark to disappear from sight is recorded. Then the experiment is repeated using the sodium hydroxide solution at 35, 40, 45, and 50 degrees Celsius. So the temperature you have to list out. Don't just write different temperature. Okay. So how about another one is the catalyst factor. Okay, for catalyst factor we can use like this.
Observe the video and the reading of the burette for every half minute for 4 minutes for the decomposition of hydrogen peroxide without catalyst. Observe the video and the reading of the burette for every half minute for 4 minutes for the decomposition of hydrogen peroxide with catalyst.
So every 30 seconds in times intervals, we'll record the volume of the gas collected. Okay, then after that we repeat without catalyst. Okay, so the presence of catalyst factor. Okay, 50 cubic centimeter of 1 mole per cubic decimeter hydrochloric acid is measured and poured into the conical flask, and then zinc granules is weighed. So burette is filled with water and immersed into basin containers of water. Okay, the water level of the burette is adjusted to 50 cubic centimeter, and then record the burette reading. Then granulated zinc is added into the conical flask. Immediately the conical flask is closed and connected using the delivery tube to the burette, and the stopwatch is started. Then the conical flask is shaken steadily. Record the volume of hydrogen gas release every 30 seconds time intervals, and then experiment is repeated by adding 5 cubic centimeter of copper 2 sulfate solution into the reactants mixture. Okay, so in the suggested answer here, we use the 5 cubic centimeter of the copper 2 sulfate solution as a catalyst. This is the catalyst. Okay, but in the video just now is using the hydrogen peroxide, hydrogen peroxide. Okay, with catalyst, the catalyst used to be manganese 5 oxide, manganese 4 oxide. Okay. Last question, question number 10. Diagram 8 shows the apparatus setup used to investigate the cleansing action of cleaning agent X and Y to remove the oily stain from the cloth. So in the hot water, it contains calcium ions and magnesium ions. Oh. So in the cleansing action A, X, the oily stain remains also. You have to know that this is salt. The oily stain removed, so this is the detergent. So this is the one you must remember. Okay, so let's see the how we do the experiment. So set 1. Okay, so in the hot water, so we stir it, the cloth with the oily stain. Okay, so it's clean. So set 2. Okay, so not clean, means that set 2 is using the salt now. So this is how we do the experiment. Now, based on diagram, compare and explain the effectiveness of the cleansing action of cleaning agent X and Y to remove the oily stain. Okay, so cleaning agent A is more effective than X. Cleaning agent Y does not form scum in the hot water, so it can remove the oily stain. So cleaning agent A forms scum in the hot water and cannot remove the oily stain. Calcium ion and magnesium ions in the hot water react with cleaning agent X, there is a salt to form the scum or white precipitate. Then it is not effective. Okay. B. Table shows the atomic arrangement of alloy P and Q. Okay, so alloy P and alloy Q. Okay, I showed you. This is solder. How to form the alloy solder.
Pure solid tin is melted. Lead is added and mixed with the liquid tin. The alloy form is solder.
Yeah. So you see, the zinc atom and the lead atom is different sizes, different sizes. So it can disrupt the orderly arrangement of the metals. So it becomes harder and stronger. Okay, so suggest the alloy P and Q. By using the alloy P or Q, explain the terms of hardness of the alloy compared to its pure metal. So our suggestion here, okay, P can be bronze or brass. Okay, Q can be brass or bronze. So see which one is your choice. So bronze, okay, is harder than copper. It's pure metal, is copper. So the presence of different sizes of the tin, okay, disrupt the orderly arrangement of the atoms in the copper. So this makes the atomic layers of the atoms in the alloy is harder to slide over one another when the force is applied. Then the layer of atom is the pure metals, like say in the copper, is easily slide over one another because it has the same size of the atoms. So when the force is applied, so the atoms can be slide over easily one another easily. But if it has the different sizes of the atoms, then it cannot slide over one another easily. Okay, by choosing either alloy P or Q, describe an experiment to compare the hardness of the alloy in its pure metal. In your description, include the label diagram, tabulation of data, and the conclusion for the experiment. So 10 marks here. So here actually we are going to do the using the functional diagrams like this. So this is a red top stand. We hang a 1 kilogram weight and clamp another ruler here, okay, to measure the height of the weight. Yeah? Then we use the different metal blocks. So first time, let's say we use the copper block, is the pure metal block. Then we put a steel ball bearing onto it and then use the slot tape to stick it. Okay. Then in order to see the hardness, we can cut the thread here. Then the weight will fall down and then knock the steel ball here. Then it forms the diameter of the dent. Then we can measure the diameter of the dent and then to determine whether the block is harder or not. Then after that, we will do for the alloy block. Okay, so this is how we do the experiment. Okay, so procedure. A steel ball is attached to a surface of the copper block using the cellophane tape. The weight of 1 kilogram is hung and at the height of 50 centimeters above the steel ball. The weight is dropped on the steel ball. Then the diameter of the dent on the surface of the copper block is measured and recorded. Then step 1 to 4 are repeated for another 2 times at different places of the copper block, so that we can take the average. Then finally, the experiment is repeated by using bronze block to replace the copper block. So we want to see the which one is harder. Okay. Then the result. Okay. So let's say copper block we do for 3 times, A1, A2, and 3. Then we take the average, divide by 3. Okay. Let's say it's A. Then for bronze, it's B1, B2, B3. Okay, divide by 3, we get the B centimeter. So as a conclusion, okay, we know that bronze has a is harder compared to its pure metal. So bronze is harder than the copper, meaning that the diameter of the dent will be, like say B will be smaller compared to A, to show it is harder. Okay. So that's all for the Perlis paper 2 essay part. If you have any question, you can leave in the comment below. Okay. Thank you very much.